we are back with some extra practice problems again from Module 12. So now we are up to number 8. This is on page 580. Number 8 says, a chemist performs the following reaction. Ta-da! If the chemist starts with 110 grams of CS2 and an excess of O2, what volume of sulfur dioxide will be produced at a temperature of 341 degrees Celsius and a pressure of 2.1 atmospheres? All right, so let's start with identifying what we are looking for. So in the problem it says, what volume of sulfur dioxide? So we're going to be looking at finding the volume of sulfur dioxide, which would be SO2. And then the things that we know that temperature equals 341 degrees Celsius. We want to convert that to Kelvin, so we add 273, so that would equal 614 Kelvin. And we know that pressure is 2.1 atmospheres, so capital P equals 2.1 atmospheres. We always know R because R is a constant. Let's remind ourselves it is 0.0821 liters times atmospheres over moles times Kelvin. And so I'm looking at, we're going to want to find V. We've got P, we've got R, we've got T. I can tell that we are going for that ideal gas law, PV equals nRT. N, of course, is the number of moles, which we don't have explicitly in the problem, but we can figure out using stoichiometry. So next we're going to figure out N. It says we start with 110.0 grams of CS2. And it says we're reacting that with excess oxygen. Okay, so CS2 would be our limiting reactant. So if we have 110 grams of CS2, let's map it out here for a minute. We're going to go from grams of CS2 to moles of CS2 to moles of what we're looking for in the problem, which is sulfur dioxide. And we can move from moles of CS2 to SO2 by looking at the balanced chemical equation. That's where the stoichiometry comes in. So here we would end up in moles of SO2, which is N, which is what we're trying to identify right now. All right, so we've got 110 grams of CS2. We're going to multiply it times 1 mole of CS2 on the top. And on the bottom, we're going to put the mass of 1 mole of CS2, which you would find from the periodic table. It is 76.2 grams of CS2. So if you cross out the grams units, 110.0 divided by 76.2 is going to be 1.44 moles of CS2. Looking back at our map, so we went from grams of CS2 to moles of CS2. So now we're going to start with moles of CS2 and move to moles of SO2. 1.44 moles of CS2 times the ratio of CS2 to SO2 in the equation. Moles of CS2 is going to go on the top. Moles of CS2 is on the bottom. Moles of SO2 is on the top. And now we're looking back at the balanced chemical equation. The chemical equation tells us that for every 1 mole of CS2, we can produce 2 moles of SO2. So 1 goes here and 2 goes here. And 1.44 times 2 equal 2.88 moles of SO2. All right, so that is our N. So now we know N equals N. Now we're going to use the ideal gas law, PV equals nRT, because we are looking for the volume, and we have all of the other numbers ready for us. So we want to get volume by itself on one side, so we're going to divide both sides by the pressure and rewrite our equation as volume equals N times R times T all over P. Now let's fill in the values for those. N is 2.88 moles times R is 0.0821. Shh, I'm going to start writing all those units. Times the temperature, which was 614 Kelvin, all divided by the pressure, which was 2.1 atmospheres. So if you put that into your calculator, you should get that the volume of SO2 equals 69 liters. We have two significant figures because we had two significant figures in the pressure back here. So that is number 8 of the extra practice problems. Numbers 9 and 10 are also using the ideal gas law and stoichiometry. Let's go on to number 9. Okay, for number 9, we also have a balanced chemical equation. I won't take the time to write it up on the whiteboard this time, so you'll just have to have your book out in front of you. But this is number 9. It says, it is difficult to make solid titanium, but since it is used in the manufacture of airplane engines and frames, it must be produced. When mined, titanium ore is mostly TiO2, titanium dioxide. To make solid titanium, the titanium ore must first be converted to titanium tetrachloride via the following reaction. So I'm giving you some background information so you can see where this is used in the real world if you decide to become a chemist, which you might. How many liters of Cl2 gas at STP would be required to completely convert 100 grams of TiO2 into titanium tetrachloride? Okay, so let's get started. Number 9, we are looking for liters of Cl2. So liters is volume, so we're looking for the volume of Cl2. And we know that it is going to be at standard temperature and pressure. So the temperature would be 0 degrees Celsius, which we want to write as Kelvin, so 273 Kelvin. We know that standard pressure is 1.0 atmospheres. Of course we know R because we always know R. So I have a feeling that the next step is going to solve for N, and they are going to give us some grams of something else. Let's refer back to the problem. Let's see, we are told we have 100 grams of TiO2. So to solve for N, we're going to go from grams of TiO2 to moles of TiO2 to moles of Cl2. So that's our plan. All right, we've got 100.0 grams of TiO2. Multiply it times 1 mole of TiO2, which has a mass of 79.9 grams of TiO2, which you should know you have to flip to the periodic table and add up the mass for 1 mole of titanium and 2 moles of oxygen, and you should get 79.9 grams. Right, so if you divide that out, you'd get 1.25 moles of titanium dioxide. Next, we are converting moles of titanium dioxide to moles of chlorine gas. 1.25 moles of titanium dioxide. We're going to multiply it by the ratio of titanium dioxide in the balanced equation to the number of moles of Cl2 in the balanced equation. So we're going to put moles of TiO2 on the bottom, moles of Cl2 on the top. Let's refer to our equation. In the equation, both of these are on the reactant side. It said that for every 3 moles of titanium dioxide, you will need 6 moles of Cl2. So let's plug in those numbers. For every 3 moles of TiO2, you will need 6 moles of Cl2. So we would multiply and divide that out, and we end up with 2.50 moles of Cl2. That is our N value. Okay, so now we're going to find the volume for Cl2. PV equals nRT. We're going to divide both sides by P so that we get volume all by itself, so we can solve for volume. So volume is going to equal N times R times T, all divided by P, pressure. Let's fill in those values. N for Cl2 was 2.50 moles. R is 0.0821. And T is 273 Kelvin. We're going to divide this by 1.0 atmosphere because that's standard pressure. So after multiplying that out, we would come out with a volume of 56.0 liters of Cl2 are necessary. Remember, the point of this problem was to see how many liters of Cl2 gas was necessary to completely react 100 grams of TiO2. And we did. We figured it out. We got 56.0 liters, so good job. I'll have one more video over number 10.